Well, we'd go to our unit circle, and I'll try to draw a unit circle right here. I would look at my unit circle, which will be provided to you. Whoa, 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 that got out of hand quickly. Well, that's not going to work. Well, that isn't going to work either. I'm going to freehand that line. Okay, so I look at where sine is square root of 2 over 2. So the first thing I'm going to think about, let's think about this whole answer. All right, sine is positive in this quadrant, and sine is positive in this quadrant. We have a positive answer, so we're going to have something in this quadrant, and we're going to have something in this quadrant. So just thinking about it, I'm going to put my points where they're actually going to be. Is this going to be one where I can add pi, add pi, add pi? No, it's not. It's going to be the one where we have to treat each one of these individually. So we're going to look at where this actually equals. So let's put the degree on there. So not the degree, I'm going to use radians. So this is pi over 4. And this one occurred at 3 pi over 4. So that means I'm just going to use alpha, the term they have. Alpha can equal pi over 4. And alpha can equal 3 pi over 4. So that I'll put an or in there. But I don't want to know what just 1 is, because it says find all the solutions. So it's not just pi over 4, it's pi over 4 plus 360, plus 360, plus 360, or pi over 4 minus 360, minus 360. So rather than writing all those out, all we do is we say, well, it's plus 360, which is pi, or 2 pi. So I'm going to say 2k pi. If you put 2 pi k, if you put k times 2 pi, I don't really care, as long as you have some order of 2, a k, and a pi. Saying that every 2 pi, I'm going to multiply by something. All right, same thing for the other one. I'm going to go around, so it's going to be the same thing. It's just going to be plus that 2 pi times k, or 2k pi, whatever order you want to put that in. All right, now I just have to put in set builder notation. Well, set builder notation I can use with alpha too. So I'm going to say it's alpha such that alpha equals that pi over 4 plus 2k pi, or I'm going to put a little different notation. I'm just going to say or x, or alpha equals 3 pi over 2 plus 2k pi, and we need to say that k is an integer, so we put that k is an element of our cap z, which is integer. Yeah?
Does it matter if you put or and?
No.
Okay.
I'm not too concerned about it.
Isn't it 3 pi over 4?
What did I put? Oh yeah, 3 pi over 4. I'm just zoomed so far in I can't actually see it, so I'm just kind of remembering, and I misremember things. But yes, thank you for pointing that out. It's 3 pi over 4. All right, any questions about any of those steps? Did we get it? People that were here, obviously, if you weren't here, it's probably brand new. But okay, do we have questions on the homework? There's one we probably should have questions on. Maybe. Yeah. 25. Maybe that's what I'm thinking of. We'll find out. So that's 6.681. There we are. Not quite, but the similar idea as the one I was going to look at. Okay, I don't know. I can't look at my unit circle to get cosine equaling 0.873. I can't look at it and actually understand that. So what you need to do is you need to put this in a form that your calculator can help solve this for you. So you're going to say alpha equals cosine inverse of 0.873. Now I don't have my calculator on me right now, so someone's going to have to help me with that.
49.2.
And is that in degrees, or is that
Degrees.
29.2 degrees?
Yeah, it was in degrees.
Okay. Now the big problem with this one is your calculator is going to give you one answer, but there's actually two answers. because cosine is positive here, negative here, but positive here. So right now I have 29.2 degrees. So one of my angles is 29.2 degrees. Well, my other angle that I need to find, so that's one. My other one I need to find is down here. Well, down here is going to be a negative 29.2 degrees. So it has two possible answers. Now, I'm not sure what the book did. Did you look up the answer at all? Did anyone look up the? Remember, that's your job for homework, is to look up the answers. That way, this is much quicker. Yeah.
I don't get why it's 360 instead of 180. Like, should I tell you the answer? Or no?
They added plus 360?
Yeah.
It should be. Because if I added 180 to this, Jeff, would that get me to an answer? So why would I add 180? I have to, since I can't add 180, I have to add 360. So I have to treat each of these individually. So like I said, I'm not sure what the book did. That was your job to look up. But one of these is going to be x equals 29.2 degrees plus 360 degrees times k. I'm not sure what the book did. They probably added 360 to this. I'm just going to leave it as negative 29.2 plus 360. Okay. Remember, it takes literally a minute to check your answers online. They're all up there. Check your answers. That's the only way you're going to do well on the test. Because if you're just mumbling your way through this and you're not sure if your answers are correct, you might be just doing it completely wrong, and you don't want to find out you're doing this wrong until the test. So make sure you look up your answers. All right, this is obviously not in set builder notation, but does it make sense how I got those degrees? All right, so for all of these, they have two answers. All right, this one has two answers. This one's going, 27 is going to have two answers, even though your calculator is only going to spit out one. And this one's going to have two answers, even though your calculator spits out one. So make sure you have both those answers for all of them. All right, you do that on a test, you lose half your points right off the top if you don't know that. Okay, other questions on the homework? Yeah?
Well, that would be like a time where we have like sine alpha equals like 4 pi over 2 or something like that.
4 pi over
Like
2.
4 pi over 7, making one up. Like one that's not on the unit circle.
Yeah,
Okay.
yep. Then you'd have,
The same way.
yeah, well, I'd put it in degrees and I'd use degree mode.
Okay.
Honestly, because degree mode is going to be a lot easier when you don't know where it is. You know, for this one, if I would have had this in radian mode, it would have come to some weird degree, and then, because more specifically on number 27, if you look at 27, and if you did, maybe I should check the homework today, because it sounds like a whole bunch of people didn't do it. If you would have actually done the homework, you would have found out that one of your degrees is actually here. I think this, if you did the sine inverse of negative 0.244, I don't remember exactly what it was, but it was something like 21 point something degrees. Yeah.
It was I got negative 14.
Negative 14, oh, I was way off. It was negative 14 point what? 0.1 degrees. All right, to get, remember we were sine, so all students take, well, sine is negative in these two quadrants. So that means my other answer is right here. Which means I have to recognize that this is 180 degrees. So this little section is going to be 180 plus 14.1 degrees. Okay, so that's probably the toughest one on there, is that you have to recognize that if I'm 14 degrees away from here, I'm going to be 14 degrees away from this guy. Yeah?
When I was plugging it in, I kept getting like more decimals, so I like did not know what to do.
When you plug this in?
Oh, I plugged in like sine to like
Oh, you had sine inverse of, you didn't come up with this? Is that what you're saying?
For like all of them, I kept getting like more decimals.
Oh, you can have more decimals, it's just rounding.
Well, but it was like point something. I got like
Oh,
I got
you-
0.246.
Okay, you're in radian mode still. If you got like 0.0 something, just check to make sure you're in degree mode. Because if you're in degree mode for this one, it makes it a little more difficult because you could do 180 plus 14.1 in your head. Because I could say, oh, that's 194.1. Got it. However, with radians, you come up to like 0.0 something. And this one would be pi plus 0.0 something, which is much harder to work. Did you get 14.1?
Yeah, no.
Okay. Yep. So make sure you do degree mode on these. It'll make your life a lot easier. Yeah.
So for 29, I
Mhm.
got tan equals 79.55.
79.55.
I was
So
just wondering how we would find the second.
okay. So let's go ahead and go through that. That's a great question.
So I know it's like it's positive in 1 and 3, but I just didn't know how to get the 25.
Can you give me the degree again?
79.55.
79 point. Okay, so that's going to be right. We'll say right here. Okay, 79.6.
5. Oh, you 6. Yeah.
I'll just say 6. All right, so we know tangent is positive here, and we know tangent is positive here. Well, the good thing is if it's in opposite quadrants like that, it means that you would add 180 degrees to get to the next one.
So would we only have one answer then?
Yep, we just add 180. Yep. So as soon as I find out it's in opposite quadrants like this, see how these are, I can't add pi to this one, so that's why I have to have two individual answers. This one's exactly 180 degrees away, so as soon as I recognize that, that's why I'm kind of training you to think about in this way. Like my sine are always going to be split into two answers. My cosines almost always going to be split into two answers. Where tangent, since our positives and our negatives are like this, they're just going to have one answer where you'd have something like x equals 79.6 degrees plus 180 degrees times. Okay. Yeah.
So then for like when like they're right next to each other in the quadrants, is there a difference of 90 degrees in between the 2 points?
Is there a difference of 90 degrees between the 2 points?
Yeah.
Not always.
Okay. So like how do we know to do the 14.1 from the 180 instead of backwards from the 270?
And in fact it won't be. Because of how the pattern of the so this is different. But if we just look at a unit circle really quick, I don't know if I have a unit circle out. I do. And it has to do with why reference angles work as well. So if you look at the pattern of a unit circle, my sine is 1/2 here, so it's plus 30 degrees. My 1/2 is here, so it's 180 minus 30 degrees. Our angles are always opposite in this fashion. That's why reference angles work, where I just figure out how to get down here, and I just have to figure if it's positive or negative. So if I have a point right here, that means the point over here is the same for sine.
Okay.
Okay? And if I have a point here, that means it's right here for sine. All right, they're mirror images of each other. So that's a good question. So if I have to add 10 here, I would just add 10 here to get to the other one here. Yep. But this is definitely not plus 90 degrees.
Yeah.
So we can't just add 90 because that would get me about here.
Okay.
So that is something we have to do and know. That's going to be on the test. So make sure you know how to do those if you're just standing there and just like, I don't know what he's talking about. All right, so if you don't have any of those notes down, good luck on the test. Okay, other questions from the homework? Because those are all really good ones to go over. Okay. Then we will do today's notes, which are almost the exact same. Almost the exact same thing as what we did yesterday, except today we might have to multiply or divide our answer. All right, so we're supposed to find all the solutions in radians to sine of 2 alpha equals 1 over square root of 2. Well, this is almost the exact same problem we just did. I'm just going to add some notes in real quick. Well, to get rid of a sign, I do sine inverse of 2 alpha, which is going to equal sine inverse. So I took the sine inverse of both sides just to show you why this works, of 1 over square root of 2. We're going to cancel those out, and we're going to have 2 alpha equals sine inverse of 1 over square root of 2. Well, this is what we've been doing the whole time. We've been asking ourselves, which angle gives me 1 over square root of 2? So we're going to do all the work the exact same, except we're going to leave this 2 alpha over here. It's just going to stay over here. So I'm going to look for where is sine inverse 1 over square root of 2. Well, we already did that in our bell work. We already did that in our bell work. We said sine inverse of 1 over square root of 2 equals pi over 4 or 3 pi over 4. So our answers are going to stay the exact same, where I have one answer here, which is pi over 4. And I have the answer here, which is 3 pi over 4. The only difference is here, I set it up as alpha equals. Down here, I'm going to set it up as 2 alpha equals. So 2 alpha is going to equal pi over 4. Well, I want all the answers, so pi over 4 plus, well, plus 180 doesn't get me to an answer. I need to go all the way around, so that's plus that 360, or that 2 pi, so it's still that 2 k pi, or 2 alpha is just going to equal that 3 pi over 4 plus 2 k pi. So everything stays the exact same. All I do is I look for this on my unit circle for sine, and I set it equal. The only difference is instead of alpha, I put 2 alpha in its place. Now I want to solve for alpha. I need alpha equals something. Well, to get rid of this 2, I just divide everything by 2. So I'm just going to divide this by 2, divide this by 2, divide that by 2. And I'm going to quickly see that alpha is going to equal pi over 8 plus, well, 2 divided by 2 is 1, so that's just k times pi. And we're going to do that exact same thing over here. I need to get rid of that 2. So I divide everything by 2. And that's going to equal alpha equals 3 pi over 8 plus k times pi. And we're done. That's it. Now we just have to put in a set built-in notation. That's all we have to do to finish this problem. And our set built-in notation is going to be x, or we used alpha. Alpha such that alpha either equals pi over 4 plus, nope, pi over 8 plus, because we have to use our new ones, plus k times pi, or our alpha needs to equal that 3 pi over 8 plus k times pi. And we just have to note that k is actually an integer. All right, so all our steps are basically the exact same. I look at this number, I either find it on my unit circle or I plug it in my calculator. And the only difference is rather than saying alpha equals, I say 2 alpha equals, which tells me I need to divide. What do you think you would do if this was pi, or if this was alpha over 2? Yeah, I would multiply everything by 2. So you may either divide, or you might have to multiply. Whatever you need to do, you need to simplify this down so it's just alpha. Even if this is a square root of alpha, you would just square both sides. I don't think that's what you'd need to do in any of those problems, but I'm just saying if that ever occurs, you're just solving for alpha for this one. All right, it's find what angle makes this true, or 2 angles, and then simplify for your alpha. All right, so we got that, and we just have one extra new bit of information. This one says, I don't want to solve for all of them. I want to solve for where it equals, where it's 0 to 2 pi. All right, I just need to find the answers that are from 0 to 2 pi, so I just want to find one full circle. Once again, all I'm going to do is I'm going to look for this tangent inverse of negative square root of 3. So I'm looking at my unit circle. Where is tangent equal to negative square root of 3? And maybe I'll write that down just for people that, when we get to the calculator one. What I'm actually doing is I'm just going 3x equals the tan inverse of negative square root of 3. So I just need to go on my unit circle, which will be provided for you, and you just got to figure out where is tangent equal to negative square root of 3. And who can tell me in degrees, what is that first angle where tangent is equal square root, or negative square root of 3? I'll wait for more people. We should all be able to look at a unit circle and figure out where tangent equals negative square root of 3. Don't rely on other people to do the work for you. Sarah?
2 pi over 3.
In degrees.
Or in degrees. 120 degrees.
120 degrees. Yeah, so it's going to be at 120 degrees, which is right here. So we have 120 degrees. The good thing about tangent is I'm looking for where it's negative. Well, tangent is negative in this quadrant, positive in our first quadrant, it's positive down here. So our other answer must be down here. The good thing about that is I don't even need to look at my unit circle. As soon as it's in opposite quadrants like this, we're going to know that just adding 180 will get me to my other point. And if you look at your unit circle, it's true that our next one is 300 degrees, right? So with tangent, we just need one solid answer, and that's going to be that 3x is going to equal 120 degrees plus 180, because 180 degrees gets me back, right? Because 180 actually gets me to my answer. Okay. Well, currently we only have two answers. It looks like we just have these two that are between 0 and 2 pi. However, I didn't divide by 3 yet. And as soon as I divide by 3, I'm going to see that I'm going to have x equals 40 degrees plus 60 degrees times k. So it's asking, I want to list every single angle that's between 0 and 2 pi. So what I'm going to do is I'm going to create a table. I'm going to create a table of values. I'm going to create a table of values. Let's see if I can do a straight line. There we go. I'm going to create a table of values that have k values and which degree results from those k values. So let's just, I forgot how many I need. Let's just make a whole bunch of lines and just go from there. All right, that might be enough. All right, so I'm going to look at where k equals 0. Well, if I plug in 0 for k, I just get out 40 degrees. If I plug a 1 in for k, I'm going to get 100 degrees. If I plug a 2 in for k, I'm going to get 160. If I plug a 3 in for k, I'm going to get out 220. If I plug a 4 in for k, well, that's 220. We're going to have 280. If I plug a 5 in for k, that's 340. 40. If I plug a 6 in for K, I'm going to have 400 degrees. But I'm looking where it's from 0 to 2 pi. What degree is 2 pi? It's 360. So I really should have stopped right here because 400 is too big. 400 is too big. So the list of my answers is just going to be a list of numbers. We're going to have 40 degrees, 100 degrees, 160, 220, 280, and 340. Now realistically I wouldn't make a table every single time. It's just nice to understand where I got that stuff from. What I would probably do is I'd recognize that it's 40 plus 60. So I would do 40 plus 60 plus 60 plus 60 plus 60 plus 60 and realize the next one is 400, so I'd stop there. Alright, so that's more or less what I would do. If you want to make a table, good. Keeps everything nice and organized and shows you what's happening. Alright, any questions about this one? Yeah?
Why wouldn't you do the thing you did for sine and cosine?
The set notation?
Yeah.
Because it didn't ask. So let's look at the questions. So this one says find all solutions. Find all solutions means I need to list every possible answer. I don't want to list an infinite number of things, so I write it in set notation. Okay, this is the list of all of them.
But it says find all solutions for tangent.
It says find all solutions to tangent in the interval 0 to 2 pi. That's why I highlighted it, because it's asking, it's a little bit different. It doesn't say I want to find every possible answer. I just want to find all the answers that are on my unit circle. That I could do one revolution, because we know it's just going to, everything else is just a repeat, realistically, because it's just a circle going around and around. So it's just saying, just go around once, and then I understand that you know what I'm talking about. So going around once just gives me these answers. I have no negatives, and I have nothing bigger than 360. Does that make sense? So be careful on what it's asking for. And if it asks for all solutions, you need to have set builder notation. If it just asks for all solutions between a certain interval, and it might not always be 0 to 2 pi, you just got to list the ones that happen to be between 0 and. Okay? Does that make sense? Yep. And a lot of these are easier if they're in degree. It's just easier to count and add. Versus, if you have pi over 4 plus pi over 8, you have to keep converting and keep converting. So sometimes it's just easier to do degrees and something. All right, any questions? Okay, then go ahead and get started.